Mr. Barry here again. We're still in the same problem. Unfortunately, we're talking about pollution control in the United States in the 80s, late 80s, mid to late 80s, I suppose. We've already entered this data into Desmos. We plotted these points. We're using 1983 as year zero and moving on from there, and in billions of dollars. And what I would like to do now is practice with you, and this kind of leads us into what we've been doing with the polynomial unit, is finding a cubic regression model. And what that will do is give us a general estimation of what this path would look like. And it's cubic, so we'll talk about that. And then we're also going to talk about something that we'll see within the data called R squared. So I'm already going to, and hopefully you kind of just saved yours. The table of values here is already entered. I already have it zoom fitted and hit the plus button on this magnifying glass over here. So we got a zoom fit. And underneath that data, what I'm going to do now is I'm going to type a cubic regression model. Now you have to be aware that we're going to be using a cubic polynomial. Biggest exponent is 3. And there's a couple different ways or different things that you need to do. So I hit the Y button here, and then I'm going to hit the number 1. And what that does for me is that 1 automatically goes to a subscript, meaning it goes underneath. It's not an exponent, it's not high up. And that Y1, it has to be Y1 because of the table of values having this at the top right there. Then I'm going to hit the tilde button. Now this is that curly line, and that kind of puts us into this regression model. So our data is going to be taking a look, well, at least we're going to take a look here at the cubic regression model. And then I want to type out a cubic polynomial. Now, when I do that, I have to understand that much like the y1, I have to have x1 anytime I have an x. So, this would be ax to the third power plus bx squared plus cx plus d. But I have to make sure I have the number 1 because it's a reference to the table of values up here every single time I type. So I'm going to type this out, bx1 second power plus cx1. So again, every time there's an x in a general form for a cubic, I got to make sure I have the x1 plus d. D we leave there. That would be the constant on the back end of our problem, or in this polynomial function. So we have a cubic regression model here, a cubic polynomial, exponent's 3. And that does a couple things for us here when it comes to taking a look. Now you might be able to take a look at this graph here, and we can zoom in or zoom out. And it's a pretty good representation of the points. You can see all the points that we typed in are somewhat in the ballpark of that cubic regression model right there. So much so that we take a look here at a statistic called R squared. And what that statistic for R squared is going to do is that helps us really kind of understand how closely the table of values matches the model that we just typed in. And we have to think of it as a percentage. So our R squared here is equal to 0.9993. All right. And if we think about it as a percentage, what that means is we move the decimal place twice. It's 99.93. All right. Now, our R squared can be anywhere from 0 to 100%. And the closer it is to 100%, the closer it is that we have a good representation of what's going on with the data and the variability that the numbers go away from that model. So what I mean by all of that is that if I have something really close to 100, like 99.93, that means that this cubic model is a pretty good representation of what's going on in that data so far, at least here. And we can use it to project later on. We'll talk about that in another video, but again, making sure we understand that using a regression model, in this case cubic, is certainly helpful for us to kind of picture what's going on in the problem.